All right, so let's take a look at this first example. The forces of static and kinetic friction are beautifully illustrated by a sticky silverware drawer in a wood cabinet. If the weight of the drawer is 7 newtons, and pulling the drawer with a force probe produces the following graph, then we can look at a few different questions. Okay, so you've got to imagine first that you've got the sticky silverware drawer that you're able to pull with a force probe or a spring scale or something like that, and you get this graph over here, this force versus time graph. Okay, so question A, what does this graph tell you about the force of friction acting on the drawer? Label the regions where static and kinetic friction are operating. Okay, so in this part of the graph, I'm going to use the highlighter for this part. In this part of the graph here, the drawer is being pulled with increasing force until a point, okay? And after that point, we get a change where now the force starts to drop and we get this sort of plateau value, okay? So this section here, when the drawer is being pulled with increasing force, this yellow section is going to be called the static friction zone. Static friction zone. Okay? Once static friction is overcome, the drawer is going to slip and you will be able to pull it out. But when it slips, you notice that the force of friction drops, right? Look at the pink section. And so when the drawer slips, now we get into kinetic friction. I'm going to call that the kinetic friction zone. Okay, so static friction zone and the kinetic friction zone. So we've labeled the regions where static and kinetic friction are operating. And now I want to actually call out the values themselves, right? So from the graph, we can see what the force of static friction is. And we talked before about how the force of static friction is less than or equal to this particular value. And what is that value? Well, look right here, right? That's the peak. And so that value is the 3.2 newtons. So less than or equal to 3.2 newtons, we're in static friction. But once we exceed the 3.2 newtons, then the force of friction drops and it levels off here in the kinetic friction zone at a value of 2.6 newtons. So I'm going to say that the kinetic friction is equal to 2.6 newtons. All right, so friction increases until the slipping point is reached, and then it drops to this kinetic friction value. And my mistake for this spelling error. All right, question B. If you pulled the drawer with a force of 3 newtons, what would happen? What about pulling the drawer with 4 newtons? So we're going to compare 3 newtons and 4 newtons. Well, if we pull the drawer with 3 newtons, then we are not exceeding the force of static friction. And so nothing would happen, right? So I'm going to say at 3 newtons, no slipping, because we haven't exceeded the force of static friction. However, at 4 newtons, we have overcome the force of static friction, and so the drawer will slide out. So I'm going to say F static is overcome. And the drawer slides out. All right, and then finally, question C. What are the coefficients of static and kinetic friction between the drawer and the wood cabinet it was stuck in? Okay, so specifically, coefficient of static friction is mu sub s. Coefficient of kinetic friction is mu sub k. All right, so remember those are the ratios between the static friction force and the normal force. So I'm going to erase those because I need the space. And I'm going to start here with the equation. So static friction is equal to the coefficient of static friction times the normal force. And I'm going to say that's actually less than or equal to, right? Well, the maximum that static friction can be is that 3.2 newtons that we identified in part A. And then mu sub s is our unknown. And then our normal force was over here. Remember that it was a 7 Newton drawer. That's describing the weight of the drawer, and so the normal force must be supporting all of that. So I'm going to throw in 7 newtons for that normal force. And so mu sub s, the coefficient, is going to be 0.46. And that has no units because when we do the division problem, it's newtons per newton. So that's our coefficient of static friction. What about our coefficient of kinetic friction? Well, to do that, F kinetic is equal to mu sub k times the normal force. From the graph, coefficient, the kinetic friction force is 2.6 newtons. Mu sub k is my unknown, and then the normal force is still 7 newtons. And so doing the algebra, right, dividing, I get that mu sub k is 0.37 newtons. Notice that the coefficient of static friction here is larger than the coefficient of kinetic friction here, and that makes sense, right? You've got to overcome static friction before you can get into the kinetic friction zone. And then I'll do example 2 in the next lecture.